We are today going to prove the relation between the specific heat at constant volume, the specific heat at constant pressure, and the molar gas constant. That is the specific heat, of course, molar specific heat at constant pressure, molar specific heat at constant volume, and the universal gas constant. Now we all know the first law of thermodynamics, which states that Q minus W equals, or dQ minus dW equals delta U. Q the heat added or absorbed or removed from the system, and W the work done on the system or by the system, and U, delta U, the change, U the internal energy. If there is increase in internal energy, delta T is positive, and there is decrease, delta T is negative. Okay, also we know that P equals RU times T, that's for 1 mole, and according to the number of moles, but PV equals RUT for 1 mole. Okay, now dQ in case of constant pressure, because we are going to compress in a closed system. We are going to compress 1 mole of a gas such that the temperature rises by 1 degree centigrade. Now here we have, according to the definition, this is Cp dt minus, since PV equals RT, but P being constant, according to our assumption, we are going to compress 1 mole of a gas at constant pressure, that is P dV, that's one differential, not P dV and VdP. P dV equals RU dt. So here Cp dt minus delta W would be RU dt equals Cv dt. Let's write it clear. Cp dt minus RU dt equals Cv dt. And transferring RU to the right hand side, RU dt, and Cv dt to the left hand side, we have Cp minus Cv dt equals RU dt, cancelling dt with dt, then RU equals Cp minus Cv. That is, the universal gas constant is equal to the difference of the specific heat at constant pressure minus the specific heat at constant volume. Note also that if dT equals 1 degree centigrade then numerically Ru times 1 and also Cp minus Cv times 1 Ru is actually equal to the energy required to compress 1 mole of a fluid regards displacement. If W equals Ru times 1, dimensionally, of course, Ru it is not equal to energy, but numerically it is equal to the amount multiplied by temperature. It is equal to the amount of work done to raise the temperature of 1 mole Ru of 1 mole of a gas 1 by 1 degree centigrade, and at the same time Ru equals Cp minus Cv. But what for 1 kilogram? This is if this is R and not Ru. Multiplying by all by the molecular weight, Ru or Cp molecular over m minus Cv molecular over m, then R per kilogram is equal to Cp specific heat at constant pressure per kilogram minus specific heat at constant volume per kilogram. That's all for today. I think I am inclined to have the next lesson. Okay, let's continue in thermodynamics. We'll prove the relation next lesson. PV to the power K equals constant for an adiabatic means no heat, adiabatic compression or expansion. And after that I am inclined to explain some air conditioning, which is a very interesting topic, air conditioning. Okay, it's not for today. Goodbye.